Okay, let's look at sigma and pi bonds and rotation around this sigma and pi bonds. So rotation's a really important point here. Sigma and pi bonds are, by the way, one of the things that's really important going forward into other chemistry classes. So just so you know, and it has a huge effect on biology and biochemistry topics as well. So if you're headed into more chemistry or into biochemistry or biological chemistry, those are important topics to get. So when we have a carbon-carbon single bond, right, it's something like that. The three-dimensional structure is kind of like a sausage shape, right? And you have three other things coming out from here, hydrogen, 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 or maybe it's three different things. It could be a hydrogen, chlorine, bromine, for example. And then you have three things on this side. We don't know what they are. Maybe this is a carbon and it has more things attached to it. And then we have another thing over here. Maybe it's a chlorine or who knows what. But these things on this end can twirl. There's rotation around a single bond. That's important. Around a double bond, however, we have the single bond in the middle. We have only two things attached to the outside. Hydrogen, chlorine, chlorine, hydrogen, and then we have this big lobe up top and bottom. It's kind of lopsided, okay? It's actually very symmetrical. And so over here, this lobe is filled with electron density, as this one is, places where the electrons are. If you try to twist this, it would break up the lobes, and this is a very strong bond. It's just as strong. Covalent bonds are very strong, and it's just as strongly attached as any other covalent bond almost. So it's not going to break, and so you cannot rotate around a double bond. And so this has all kinds of ramifications. You've heard of trans fatty acids, the difference between a cis fatty acid, which your body can digest, and a trans fatty acid, which your body recognizes as an invader and some kind of toxic thing that is bad for you, is that the one is rotated differently than the other. And in a long chain fatty acid, which is like a long chain of carbons with stuff at the ends. So this rotation business, not being able to rotate around a single bond, around a double bond, is pretty important. So why can't you rotate around a double bond? Because we have this pi bond here that is not symmetrical around the axis. If you would look the axis straight on, the electrons would not be along the axis connecting the two atoms. They would be above and below that. So if I were to hold these markers, say this is my sigma bond, here's the one nucleus, here's another nucleus, and then I'm holding these two markers. I don't know if you can see this very well in the video, but maybe I'll turn this one around. This tip with a lid on, that one is our sigma bond. It's adjoining the nucleus and the nucleus, right? And so with that, we can twist, and it's just fine. But if I try to twist this one, I can't do it, right? It would break. Oh, that was handy. So it would try to break. All right. So no rotation around a double bond, rotation around a single bond.